All right, hello everyone, this is Mr. Crozier. I'm going to go over review packet number 1 and some problems on it that people asked about. All right, very first problem right here. It asks for, 1 second, I am fixing the setting on it. All right, it is asking for the change in rate, how fast is the radius. So it's asking for dr dt. Well, if you take the derivative with respect to time, now we have dv dt is equal to 4 pi r squared, dr dt. Plug in everything you know, solve for what you don't. On number 3, mean value theorem. Mean value theorem is there's a spot where the slope is equal to the derivative. And that's what this is. I found the slope, set it equal to the derivative. On the second page, number 8. We're finding the tangent line. A tangent is an equation of a line, and this is one form. Now, if needed, you could switch it into y equals mx plus b. It's the same thing, but I found the point, found the slope, and I wrote it in point slope form. On number 10, find the limit as x goes to 2 from the positive side. That means I would use this. Find limit as we go to infinity. I plug in infinity, goes to 0. Now when it says the limit goes to 2, for a limit you must check the left and the right hand side. So we're going to check both of these. So they do not match, it does not exist. And the last one we just check 0. Horizontal asymptote is when we go to infinity or negative infinity, and what you do is you just simplify this all the way down to just the highest power, and that comes down to 1 over x. Now if you plug in both of these, they both go to 0. On number 3, it's a maximum equation problem, and this is the picture. We have a wall, a fence, we have this much fencing, and we need this much area. So we're going to max this equation by solving this here, plugging it in. On number 13, true and false, there is a limit to 4. Both the left and the right, this is supposed to be greater than only. Both the left and the right go to 3. F of 4 is here, but it's not continuous. If you look at the graph of this one, what you'll find is it graphs like this, but at 4, the value is 2, however, the pieces are going to 3. Average rate of change is nothing more than slope. So I use these points in the slope formula. Number 15, as we go to 3, the graph goes to 1. The value at 3 is 2. 4 from the right-hand side, that would be this spot here, is 3. There is no limit at 4 because the points don't match. F of 2 is not defined, and F of 1/2 is about 3.5 right there. Number 20, end behavior is when you plug in infinity. This is infinity. This is 1 over infinity, which is 0. So the graph of this will look something like this. On the left-hand side, it's going up to infinity. On the right-hand side, it's an asymptote at 0. On the back, take the derivative with respect to time. You're going to have to figure out what the y value is by plugging in 3. 3 gets plugged in there, and then you can figure out y. You can do the math there. On 34, you have to find when the velocity is equal to 0. That's what this line does. Velocity is 0 is at 18. Now we plug in this up here to find that value. 23, kind of a trick problem here. They want dv dr, so we're going to differentiate with respect to r. A lot of times we make that t. In this case, it's r, meaning dr at the end here goes away, and we just get 5, plug in 5 for the radius, and we get that answer by plugging in 5 right there. 34. A lot of people don't know what to do with e to the pi. E to the pi is a number. If I were to type that in my calculator, let's see here, e to the pi is about 23.14. So that's just a number. Any constant does not have a derivative. You can do the math and get all the way down to ln of x. 35, again, it's a tangent line. We have a point, slope form, And the answer key does put it in this form here, but I always recommend you start here and then go to there. Absolute extrema. Endpoints and critical points, test them all. 38. Marginal profit means just the change in profit. So we have this equation that gives the change. We plug in 893. It's the slope at that point. At that point, that's what they're making for each change. Number 40. It's continuous all the way through. However, right here it's not differentiable. And that's how I can write this. It's continuous across the whole thing, but it's not differentiable at 2. There's this break. There's one section, second section. It's not differentiable. The amount of bacteria in a culture. Use a calculator for 41. You can do it analytically, but it's a little bit complicated. If you just use a calculator, you will see there's a max right there at number 1. 42. Again, mean value theorem. Let the slope, which is -1, be equal to the derivative. 45. Tough equation to solve, but after you do left d right plus right d left, you have this. If you factor out an e to the t, now we have two parts. This is 0. This can be 0. And doing this to be 0, it's we solved this equation in trig last year, but if you have cosine plus sine, subtract this over, divide by cosine, and you get tangent. So those are the tangent values. 46 is simply the second derivative. Take it once, take it twice. 49, kind of a trick problem here. We want max velocity. So if this is my position function, if I differentiate that, this is my velocity function. Well, if I want to max this equation, in order to maximize an equation, I need the equation's derivative. So we do have to take another derivative because we're not looking for max height. We're looking for max volume, so we're differentiating this one. You can find the critical point as 1, plug it back in there. This is simply a graphing calculator problem. If you graph this, let's see if I can get this picture on here. If I graph this, you got to be real careful, 4x divided by all of this in parentheses, there, t0. So in my window, I'm just going to make t positive. Let's just go to 10. So this is where I always start. I always start with something like 10 to 10. However, I know it has to be positive, so I don't need any negatives. If I hit graph, that's what I get. What you notice is it's a very small graph. It just goes between 0 and 1. So I'm going to switch this 0 to 1, and now graph, and there's my graph, and there's a max. I could even make it a little bit better. Let's only go up to 0.5. It goes up and down, so there's a maximum right there. Let's calculate that. Second calc maximum. It asks for a left bound, so I'm going to go left of it. It asks for a right bound, I'm going to go right of it. It asks for a guess, I'm going to guess, and there's my maximum. After 2.51 hours, the percent is the highest. Derivative, make sure you know this is a 3-part process. It is 1 over 6x times 1 over ln of e times 6. 3 parts. If you are doing the log of anything, the derivative is 1 over u times 1 over ln of a times u prime. 1, 2, 3. That's 1. Then that goes to the numerator, and that gets divided out. You're going to want to make sure you memorize those steps for that. On 56, it's a Pythagorean theorem, related rates. Take the rates. You're going to have to do some math to figure out those. Solve for what you don't know. On the bottom one, left d right plus right d left gives you this. And you can, let's see here, there's my, what I did was I multiplied this in there. And then I went ahead and did left d right plus right d left. Those will cancel out, and now you have 2 parts. This can never be 0. That can be 0 at 0 itself. There's your first derivative test. It goes down, then up. Number 60, we have a related rates problem again. So we take this with respect to time. However, it doesn't tell you the radius, but it does tell you that it's going up by 4. So 12 seconds later, the radius is 4, so you can use that in your function. That's kind of hard to come up with right there. Everything's easy except that part of it right there. 12 seconds, 12 groups of 4 is 48. On the back, 63, take the derivative, set it equal to 0. And in this case, this critical point is a minimum. Don't get tricked by that. The maximum occurs at either -2 or 5. If you plug in both of those, you'll see 5 is the highest. But what you found here is a minimum, and you are asked for a maximum. So you always have to do that test to be sure you found the right extrema. 62, x times y is 48, 2x plus 3y minimized. Solve it, put it in, do the computation to find the last one. And 65, those are our tangent approximations. This comes from point slope formula. T of x is equal to y1 plus the slope x minus x1. Same deal here. The table for this one is up here. And the last problem, it's just a chain rule problem. I multiply this down, subtract, and then don't forget to add on the chain rule. The chain rule is the derivative of the inside function. This function here is inside this cubic function. So we go there. And also, don't bother simplifying this. If you're plugging in 2, plug in 2 here. This is 4, 2 cubed times 1. You can do the math. All right, hope this helps with your final preparation.